Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 2, and we are continuing our investigation of trigonometry. Now, in the last episode, we looked at the distance formula, how to find the distance between 2 points. And if I recall, that equation was distance between some point P and Q is going to equal the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And we are assuming that P is x1, y1, Q, I think we said it was x2, y2. Now, it doesn't really matter which one you call x1, which one you call x2, as long as if P is x1, if P has the x1, then it has to have the y1. You can't have like P be x2 and y1, for example. So the subscripts to 2's have to go together. The one subscripts, they have to go together. You can't mix them up. But it doesn't matter if you call P x2, y2 and Q x1, y1. The equation will work out the same. So you will get the same answer regardless of which one you plug, what numbers you plug in for x1, x2, etc. Alright. What we're going to do now, though, is consider a circle. So, when I think about a circle, what we know is that circles have a radius r, and this is a set distance from some center. So this dot right here is our center, and no matter where at I draw a line, so I can draw this line here, that will have the same distance. So this red line, the blue line, these green lines, each of those is a distance from the center to our edge of the circle of a distance of r. So if I consider now some point, we'll call this about x comma y. Alright, and I think we'll just call this center about hk. Okay. Now I could think about this in terms of a distance formula. When I think about this, the center, and our point over here, I guess we should probably just call it something, so we'll just call it P. Distance from center to P, that distance is the radius, but it's also asking a question, what is the distance between 2 points? In other words, we can use the distance formula. So the distance between, we'll write it out, distance between P and the center, that has to equal the square root of x minus h, that quantity squared, plus y minus k quantity squared. But this distance is nothing other than r. So this is equal to r. This is equal to r. So this right here, we have this nice equation here from the distance formula. But if you were to plug this into your calculator, I claim you would only get actually half of our circle. So in order to get the full circle, I'm going to actually square both sides. So r squared is going to equal the square root of x minus h quantity squared plus y minus k quantity squared. Oh, why did I do the square root? Silly me. We don't want that. Alright, there we go. So this right here is going to be our equation of a circle. So equation of a circle. Alright. So if you have some radius r and then a center at hk, then you can generate a nice equation for a circle. So for example, if the center, I'm going to just use a c in parentheses, so if the center is at -3 comma 5 and our total radius is 4, then our equation for our circle is going to equal, we have to have r squared, so that's 4 squared. I think I'm going to erase that and use a colon at the bottom here. So there we go. So the equation of our circle is going to be 4 squared is equal to x minus, so one thing to note, this is going to be our h, this is going to be our k, right? Because that's the center. So if we look at the picture here, right, we are making use of these two values. That's our hk. So that's why we're going to have x minus -3 comma squared plus y minus 5 quantity squared. So 4 squared is 16, and then x minus -3 is positive, so x plus 3 quantity squared plus y minus 5 quantity squared. So this would be the equation of our circle. This would be our answer if this is what we were asked to find, which indeed was our example. And similarly, I could give this equation, say 100 is equal to x minus 3 quantity squared plus y plus 7 squared. So if you want to know what the radius is, what we can note is that this value here, this 100 is equal to r squared, so then we can just square root both sides, right? So 10 is going to equal r. And if we wanted the center, what we want to note is these two values right here. So the center, now we got to keep in mind something very sneaky here. These two values, the 3 and the 7, are related to our center, but we must pay attention to the fact that in our general equation, we already have a negative. Look at that. So that means this negative right here, we can ignore that first negative because it's accounted for by our general formula. So this is actually going to be a positive 3. Now, when I look at this one over here, I have to kind of undo how my brain would normally think about it, because I would be inclined to put a positive 7 here, but this is actually a y minus -7, because you have to have a negative from the formula. See, one negative from the formula, I don't see any negatives. That means when I introduce one, I have to have a double negative. So the center here is actually going to be at 3 comma -7. Alright, we'll box our answers. So if I give a general equation, I can look at it and say what is the radius and what is the center, just by looking at those quantities there, and that box in green and blue. Alright, so that is looking at in general what our circle is. There's really not too much to it. The idea of a circle pretty much follows directly from our distance formula here, as long as we kept in mind the geometric definition of a circle as having a center with and it's generated by just rotating a fixed length around that center. And once we did that, we were able to solve for our equation of a circle. This is our new fun fact, and we could see how we can just once we have like a radius and a center, we can generate an easy equation, or just looking at an equation, how we can discern what is the radius or center of them. Alright, now for our next topic, we'll make a new video for that, and it's going to look at what happens when you have, say, a circle intersecting a circle, or a circle intersecting a line. How do I find those points of intersection? And that's what we'll talk about next. So If you've enjoyed this episode of Math with Haas, please consider subscribing to our channel, supporting us on Patreon. Thank you for joining the math party, and I will see you next time.